All right, multi-step equations with variables on both sides. And away we go. Example 1. So I've got negative 3/4 times negative, and I'm going to go ahead and put the 1 there so I don't forget, is equal to 1/2 6x minus 10. Okay? Multi-step equations with, oh, that's the homework. Oh, never mind. Oh, good. I'll do the homework, huh? All right. Dang. Thank you for asking. All right. So number 1. 6 plus 1/3 times 1x minus 9 is equal to 1/2 times 2 minus, and I'm going to put that 1 in there every time, okay? You guys really need to do that. All right, what a mess. So let's do what we need to clean up. There's nothing we can do inside the parentheses, so then we're going to do our multiplication first. 6 plus 1/3 times 1x is going to give me 1/3 x. A positive times a negative is going to give me a negative, right? And I'm just going to come over here and use this as my little workspace. So if I do 1/3 times 9/1, I end up with 9/3, which is what? 3, isn't it? And I'm going to have a negative because this 9 was negative, not the 1/3. And so that's a -3, so there's my -3. Okay? Is equal to, all right, I got 1/2 times 2/1, which is going to give me 2/2, which is going to give me 1, correct? So I've got 1, and I've got a positive and a negative, so I know it's going to be a subtract. I've got a 1/2 times 1, which is what? 1/2 x. All right. What a mess, huh? So let's combine our variables on the same side first, okay? So I mean our constants, because we have 6 and we have 3 on this side. So that if I combine those, it's going to leave me 1/3 x. A positive 6 and a -3 leaves me positive 3 is equal to 1 minus 1/2 x. Okay? Next, I'm going to get my constants on the same side. So I'm going to subtract 3, and it wouldn't matter if you did your variables first. You're all going to end up the same. 1/3 x is equal to -2 minus 1/2 x. You could do your variables first. Doesn't matter. Same thing, same results. All right. I guess I'm going to add 1/2 x to both sides. And I end up with -2 on this side and 1/3 plus 1/2. Well, let's see here. 1/3 plus 1/2, and I'm going to change them to 6. So I get 2 6 plus 3 6, which is 5 6. Now, I haven't taught you, but you could come over here and you could have done parentheses. 1 divided by 3, parentheses plus, parentheses. 1 divided by 2, parentheses. You would hit enter. I'd go back to math. Enter, and keep it as a fraction because you can't deal with this number. That's what I'm saying. Keep them as fractions, all right? We can deal with fractions. We can't deal and computate with 0.833333333. Okay? So don't do it. Leave them as fractions, all right? So I could have done that, all right? I've got 5 6x. And now I want to get rid of that wonderful fraction next to my variable. So I'm going to multiply this side by 6/5, multiply this side by 6/5, and that cancels that, that cancels that. I end up with x is equal to, all right, negative 2 times 6/5, and I end up with negative 12 over 5. And that is how I'm leaving it, people. I am not leaving it as a decimal. I'm leaving it as negative 12 over 5. Everybody good? Okay. Yes, no, maybe so? Okay. All right. Let's do the next one. 5 minus 3 times x minus 7 is equal to 2 times 2 minus x minus 8. I forgot to put my ones. I'm going to go back and put my ones. What do I need to do first? Just take one side on at first, okay? Look at it. What do we need to do here? Okay, so negative 3 times 1 is negative 3x. Negative 3 times negative 7 is positive 21. I got an equal sign. 2 times 2 is 4. 2 times negative 1 is negative 2x. And I still have this negative 8 out there. I know some of your writing is horrendous, okay? In order to keep equations, you kind of got to get things and get that step-by-step pattern and, you know, I guess you can read your own writing, but some of you are like doctors already. You haven't even gotten there yet. Imagine what your writing's going to be like when you get there. All right, so here we go. We're going to clean it up. I'm going to clean this side up because I have two constants. So I'm going to put negative 3x, and 21 and 5 is a plus. 26 is equal to, we'll clean this side up. I got two constants, so I'm going to put negative 2x. I got a positive 4 and a negative 8 gives me a negative 4. This is why you needed to know your integers, okay? If you have to, use the calculator to double check, all right? All right, I am going to, now, this is my preference, okay? My preference would be to bring my negative 3 over. Why do you think I would prefer to do that? And bring my negative 3 to the right and bring my constants to the left. I'm going to do this. Okay. This one, I'm going to, your probably first thing would be to bring this 26 over here. Yes? Is that your first thought? Most of you. You don't know what you would do. Is that what you're trying to say by not answering that question? Most of the time, most of us are most comfortable with our variables on the left. Do we agree about that? Yes? Okay. So if I add 2x and I add 2x, okay, then I end up with negative 1x plus 26 is equal to negative 4, don't I? Then I would subtract 26 on both sides, and I'd end up with negative 1x is equal to negative 30. Then I'd have to divide by negative 1 or multiply by negative 1 in order, because I can't leave my variable negative. Is that correct? So I'd end up with x is equal to 30 after I multiplied both sides by negative 1 or I divided by negative 1. It doesn't really matter which way I did that. All right? Now, the reason I would, when I'm looking at these, I know that 3 is a bigger number than 2. Okay? I'm already thinking ahead. All right? I know that I need to leave my variable positive. So here is an upper level. Once you get there, you'll maybe start thinking this way. So I would add 3x to both sides By doing that, I've got a positive bigger number and a smaller negative number. So I'd end up with 26 is equal to 1x minus 4. Add 4, and I end up with x is equal to 30. So all I did was save myself that last step of remembering to change my variable to positive. Okay? And there again, do what you're comfortable with at first, all right, and get it down. Then if you start seeing that, then go ahead and go there, all right? But get yourself comfortable before you necessarily jump here, but that's why I would go this route. I'm comfortable with a variable on either side. It doesn't bother me. You still may be comfortable with your variables on the left, and that's great. Then do what you need to do to get there. Okay? Deal? You guys are too quiet. Lord have mercy. All right, here we go. Example number 2. 9 times the quantity of a number. Why didn't I end up with a paper? That's why I was trying to do the homework, because I didn't have one of these. All right. 9 times the quantity of a number plus 4 is 8 more than 5 times the number. What is the number? So I'm going to do this. 9 times, I've got 9 times the quantity of a number. So of a number is going to be my variable. Plus 4 is 8 more than. Remember when we have more than, what do? It comes what? After the what? The variable, okay? Less than, more than, greater than, whatever, however they state it. If there is a than after it, that means that you need to put that number after your variable, okay? I can't stress that enough. It doesn't really make a difference with addition, but it makes a huge difference, right, Luis? We found that out yesterday. It makes a huge difference with subtraction, okay? All right, so I've got 8 here more than, so I know 5 times a number. So I'm going to have 5n, and I've got to have a plus, but this is going to have to come after, so I'm going to do plus 8, right? It says, what is the number? So that's my question. I let n equal the number. Okay, and my question is, what is that number, right? So we just need to go and do the little work, and this one isn't too bad, so we can go ahead and work it here, and we will do 9n plus 4 is equal to 5n plus 8. Okay, simple Simon here. Let's subtract 4. Subtract 4. If you notice, I chose to leave, I'll show you here. 8 minus 4 is 4. Subtract 5. Subtract 5n. And I end up with 4n is equal to 4. Divide both sides by 4. And I end up with n is equal to 1. Now you have a calculator, right? So I could very easily, because I want to make sure that I'm getting these answers right, I could do, well, 9 times 1, I actually could do this in my head, because it is a 1. It's so simple. 9 times 1 is 9, plus 4 is what? 13, right? So then I've got 5 times 1 is 5 plus 8 is 13. Well, 13 equals 13, so now I know I have the right answer. Okay? If this work wasn't so simple, I could put whatever my calculation is in my calculator and find the answer, and then do the same thing on this and make sure that they equal, okay? So just a thought, okay? All right. Write and solve an equation. Only an algebraic solution will be accepted. That means you have to have an equation, okay? So 5 less than 4 times a number is 9 more than twice the number. We've got these lovely things again. More than, less than, don't we? Okay. So I'm going to do the same. I'm going to let n equal the number. And I've got 5 less than, which means I'm going to have a subtract, right? Somewhere 4 times a number, but I need it to be after because of that less than. Here's my equal sign, 9 more than. There again, that's going to be a plus twice the number. So pretty much, there's my equation. I'm just going to do this. 4n minus 5 is equal to 2n plus 9. Now, you would get a whole different answer if you put in 5 minus 4n, okay? So you don't want to do that. You want to make sure that when you see these things, more than, less than, that you always put the number after the variable, okay? So I'm going to add 5. 4n is equal to 2n plus 14. Subtract 2n. I get 2n is equal to 14. Divide by 2, and I get n is equal to 7. Since we can't see that so well, I will write it over here. So if I had 7, 4 times 7 is 28, minus 5 is 22, correct? 2 times 7 is 14, plus 9, ooh, 23. Well, hold on. 4 times 7 is 28, minus 5 is 23. That's my problem. And 2 times 7 is 14, plus 9 is 23. So it is checked, and I've got my answer correct. Alrighty, let's move on. Deborah has 2 paintings in her portfolio and paints 3 more each week. So she has 2 and she paints 3 more each week. Each week is your what? Variable. Okay? So we could do W, we could do X. What do you want to do? W. Alright. Kai has 12 paintings, so I've got 12 here in her portfolio, and so and is going to be a plus, right? Paints 2 more each week, so 2 more each week. So there's your variable, okay? After how many weeks? So question is weeks. Well, they have the same number of paintings. Same number of paintings means we're going to have an equal sign between the two, right? So how many weeks? Same. And you can, I'm just trying to get this information so that I have it square. Deb is what? 2 plus 3x. Right? It doesn't say more than, right? So 2 plus 3x, and Kai is 12 plus 2x. So I just need to set them equal to each other. Oh, I'm sorry, W. We agreed on W, didn't we? Let W equal number of weeks. And I'm doing this and setting these up because eventually they get harder. So if you establish a pattern, I know that you may not need to write all this detail down now. Some of you may, some of you may not. But as you do this, you will set yourself up for success later. Okay? So I've got Deb, 2 plus 3W is equal to 12 plus 2W. Let's see. I'm going to subtract 2 from both sides. I get 3W is equal to 10 plus 2W, subtract 2W, and I end up with a very small place to write 1W is equal to 10, don't I? So W is equal to 10. So 10 weeks, 30 plus 2, because if I substitute 10 in here for W, I get 30 plus 2, which would be 32, and I get 20 plus 12, which is equal to 32, so I know it checks and it's correct. Right? All right. Jake owns twice as many DVDs as Lewis. Bo has 60 fewer DVDs than 5 times Lewis's collection. If Jake and Bo have the same amount of DVDs, how many DVDs are there? All right, so I'm just going to use let X equal what? Well, let's see here. We know Jake owns twice as many as who? Lewis. So if they have based everything on whose DVDs? Lewis's DVDs, right? Because Bo has 60 fewer than, we got that, ooh, fewer than, right? Ooh, that's an important key right there. Then 5 times Lewis's collection, right? So let's let X equal Lewis's DVDs, okay? So we've got Lewis, we know we've got Jake, and we know we have Bo. Lewis, if he's X, how are we going to write Jake's? Jake's is twice as many as Lewis, so that's going, if Lewis is X, this is 2X, right? Does that sound right? 2X. Bo has 60 fewer than 5 times Lewis's, which is X, correct? So, fewer than, where are we going to put that 60? It's going to be 5X minus 60, correct? Okay? These aren't hard if you break them down, all right? So, now we've got what? What is the question? How many DVDs are in Lewis's? So by solving for X, we're just solving for Lewis's, right? We don't even have to figure out how many Jake or how many Bo have. So we've got this. 2X is Jake is equal to 5X minus 60. Correct? What? Okay, so if I move the 5x, I end up with negative 3x is equal to negative 60. I could have just, well, either way you would have ended up doing 2 steps. Divide by negative 3, and I get x is equal to 20. So let's see here. Does that make sense? If Lewis has 20, Jake has 2 times 20, that would be 40. And 5 times 20 is 100 minus 60 would be 40. And do you see how that should make sense because 40 and 40 have been set equal to each other? Okay. 2 times 20 is 40. This would be 40 and 40. So that makes sense. So this is Lewis's DVDs. Okay. I love these kind of problems. The square with a side length of x plus 3 and an equilateral triangle with a side length of 3x minus 1 have the same perimeter. What is the value of x? Ooh, ooh, ooh. All right, so tell me something. How do you find, let's do this here. Example 4. How do you find the perimeter of a square? You have all these sides, and it says the square with the side length of x plus 3, correct? So you would add all those sides, right? Okay, because this one's x plus 3, x plus 3, x plus 3. And yes, I could sit there and do x plus 3 plus x plus 3 plus x plus 3 plus x plus 3, right? That's the long way around, isn't it? How many sides does a square have?
4.
What's the side length? So, really, the perimeter of this square is represented by 4 times x plus 3. Do you agree? Yes or no?
Yes.
All right, tell me about an equilateral triangle. What is it about an equilateral triangle? Why is it called an equilateral triangle? All the sides are the same, and it says that this is 3x minus 1, this is 3x minus 1, this is 3x minus 1. So if all the sides are same, how many sides do we have?
3.
All right, and I'm really kind of writing this out so that you get, because these are awesome questions in algebra, okay? So how can I find that out? How I could do 3x minus 1 plus 3x minus 1 plus 3x minus 1. That's the long way around. What's the perimeter? 3 times 3x minus 1. Okay? So they're saying that they have the same perimeter, so we can set them equal to each other. So 4 times x plus 3 is equal to 3 times 3x minus 1. And their question was that what's the value of x? So we just need to solve for x. 4 times x is 4x. 4 times 3 is plus 12 is equal to 3 times 3, 9x. 3 times negative 1 is negative 3. I'm doing this. I'm bringing this negative 3 over. I'm going to add 3 to both sides. I get 4x plus 15 is equal to 9x. I'm bringing my negative 4x over here, so I save myself a step. I've got 15 is equal to 5x. Divide by 5, and I've got x is equal to 3. I know that, in this day and age, oh, I missed it. You guys missed it. In this day and age, save a tree, excuse me, but I would say in this day and age when you're doing algebra, don't save a tree and make sure you leave yourself enough room and you don't squish your numbers together and just work the problem down the page, okay? Also, too, if you haven't noticed, if I find on your work that your answer is correct, even when you transposed it onto your worksheet for me to check that it was wrong, I generally will go look on your work. If I can read your work and find out that you actually had the right answer on your work, I'm not going to mark it wrong. I'll circle it and say, be careful, look at work, or something like that. So it always is in your best interest to make sure that I can read your work and that it's not all scrambled around and that I can find the problems somewhere, doesn't necessarily have to be in sequential order, but they need to be numbered somehow so I know what they are. And that if I can read it and I can follow your line of thinking and you get the right answer, sometimes it's really easy to forget that negative sign when you're putting it onto your worksheet or whatever. So just so you know, I do look a lot of times, especially when it's like just a negative sign or a positive sign or something like that, to see if you got it. So here I would put x is equal to 3. If I wanted to check it, I'd put 3 in here, and I'd say 3 plus 3 is 6. 6 times 4 is 24. Then I could do 3 times 3 is 9 minus 1 is 8. 8 times 3 is 24. So yes, it checks off, doesn't it? Okay? All right, last one, which is very similar to the one we had, only they want you to find the perimeter of the square, okay? So a square and an equilateral triangle have the same perimeter. Each side of the triangle exceeds the length of the square by 4 inches. What is the perimeter? So I have a square and I have an equilateral triangle, and what they've told me is that the side length of the equilateral triangle is based on what? the information from the side length of the square. So what we're going to do is let x equal side length of the square. Okay? So if I know this is x, this is x, this is x, this is x, what is my equilateral triangle? What's the side length there? X plus 4, because it exceeds. Okay, x plus 4, x plus 4. So how many x's do I have for perimeter here? This is really 4x, right, for perimeter? Okay, how about here? It's 3 times x plus 4. So set this up. I've got 4x is equal to 3 times x plus 4. I end up with 4x is equal to 3x plus 12. I'm going to subtract 3x from both sides. I get x is equal to 12. And it asks for the perimeter of the square. So I want to go back and do 4 times 12, which is going to be what? 48 inches, right? Okay, is my perimeter of the square is 48 inches. All right? Good? Yes? No? A lot? You guys.